Numero 5, number 5 on the vectors worksheet says that there is a hiker that walks 65 meters west and then 145 meters at 10.5 degrees north of west. What is the distance that he walked? What is his displacement? Okay, so there are two motions here. One is purely west. Never eat soggy waffles. Okay, west. That's first motion. We're going to add, remember this is we are adding vectors. So the other vector that we add is the 145 meters, and that's north of west. Okay, so also some west, but a little bit of north in that as well. So this one, we have a resultant. Okay. The first black line over here on the left and this red line are the two motions. Okay, the black lines underneath this red line on the triangle, that's what we're trying to do to split it into and say, okay, if we go in this direction, then how much horizontal distance did we travel? How much vertical distance did we travel? And that would be north and west. Okay, so we know this is 145 meters. This is 65 meters. And we know this angle is 10.5 degrees. So I've drawn it a little bit too much, too large. That's okay. All right, that's a displacement in the x direction from the second part of the movement. And this is a displacement in the y direction from the second part. Let's do the x's first. Okay, from this first motion, delta x1 is 65 meters west. Okay. All 65 meters straight west, no vertical, no north or south change. 2 in the x direction, okay, we've got the adjacent side to this 10.5 degree angle. So if we do the adjacent side divided by the hypotenuse, 145, we get cosine of that angle, 10.5 degrees. X2 is 145 cosine of 10.5. And that number is 142.6 meters west. That's this length here. And so let's take this number and this number and let's add them up. Let's get the total displacement westward. 65 plus 142.6. That gets us 207.6 meters west. All right, now let's find this y component. Okay, we know that this is opposite. We know the hypotenuse, so sine of 10.5 is equal to the length of the opposite side over the hypotenuse. So that change in y2, which is the only change in y, is equal to 145 sine of 10.5. And 26.4, or yeah, 0.4 meters towards the north. Okay, we're looking at our totals. We're going to use our totals, so we have added the components x and y, and so we're now going to put them back together, reassemble them. Okay. We've got a lot, I should say, of westward. We got a little bit of north, and the resultant is this dashed line here. Okay. That's just straight line we're looking for. So it asked the distance that he walked. Let's get that one right away. Distance that he walked is just, he walked 65 meters and then he walked 145 meters. So the distance is equal to 65 plus 145, that's 210 meters. about his displacement? Okay. So we're going to do 26.4 meters, and that's towards the north. We got 207.6 meters, and that's towards the west. And we want to find this displacement here. Displacement. So 26.4 squared plus 207.6 squared. Take the square root of that, you get 209.3 meters. Displacement there is 209.3 meters. Let's see, we've only got two significant figures here, so I'm going to have to round that off to 210, which is actually the distance that he walked. And what is his displacement? So 210 meters, that's a distance. We have to know the angle if we want to tell displacement. We have to give some direction to that. So to find theta, again, you're going to do tangent inverse of 26.4 over 207.6. Tangent inverse. 7.2 degrees. Okay, and pause this if you have to assign the direction. I'm going to say the direction that this is in, but you have to be able to figure this out. Not west, okay? If we said west, we would be wrong. There's a westward portion of it, but we have turned towards the north from the west. So we would say north of west. I didn't go west, I went a little bit north of west. Well, how much? 7.2 degrees. There's your displacement.